I'll be talking about a much more focused project, much more limited in scope, but hopefully somewhat interesting. Our research is motivated by obviously the recent growth and diffusion of online peer-to-peer marketplaces, Airbnb for renting people's apartments, and Uber for ride sharing are just the two most popular examples. These marketplaces have received a lot of media attention, partly because of the regulatory issues that arise with them, but also because of the very interesting problems that... can you see everything? I'm not sure you can see all of the slides. And so they're very interesting because of all the exciting economic problems that arise in creating well-functioning and efficient marketplaces that match many fragmented buyers and sellers. And from our perspective, what is a key feature of these marketplaces is that they have a varying level of buyers and sellers, varying across cities and over time. And that these buyers and sellers use basically similar rules of interaction. And so we can actually observe multiple markets and estimate something useful about the utilities of the buyers and sellers participating in these platforms. So let me be specific about this. If you think about Uber, about using Uber to get to the airport, you want to find a ride right here and right now. You're not interested in finding a ride that's 1 hour late or somewhere else. At the same time, if you want to look for a room on Airbnb for this workshop, you want it probably close to campus and for the right dates. And when these markets are temporally and geographically defined, there can be large imbalances between buyers and sellers. This is just an example taken from Uber in Philadelphia. You can see that there's a lot of peaks both within a day and across the week, and I'm sure Chris is going to talk about this later this afternoon. And a basic problem for these marketplaces is understanding how the market equilibrates when there's these large demand and supply imbalances. We're going to study this question on TaskRabbit, which is a two-sided platform for local services. You can think of a place where you can find someone to build your IKEA furniture for you. We're going to look at the platform between June 2010 and May 2014, which is the period in which buyers would post tasks like this, and sellers would search through these tasks and then submit offers, very much like a procurement auction for most of the tasks. This is a very local platform. Buyers and sellers use the platform just within their city. More than 96% of sellers and buyers submit offers or post tasks in only one city in a given month. And at the same time, matches have to occur quickly. Not as quickly as on Uber, but about in a matter of a couple of days. And this is the typical demand that I want you to think about. This platform is used for moving help, for home repairs and spring cleaning. And of course, because it's flexible enough to adapt to very heterogeneous demand, there's also some atypical tasks that are being posted online, like pet sitting for your goldfish or help from MacGyver. But really what this paper is about is not so much about the heterogeneity of the platform, but about the aggregate market averages for the standard tasks. And so if we plot the number of posted tasks in a given city over time for each month, you can see that the platform has been growing over time. But you can also see that the number of approved sellers has been fluctuating a lot, so that there are months in which demand is high relative to the number of approved sellers, and there are months in which demand is fairly low relative to the number of approved sellers. So when there are these fluctuations, the most obvious candidate to clear this market is price, which should be high in principle when demand is high and low otherwise. But surprisingly enough, the average price stays pretty constant at about $60. And you can think of this price as the price paid for a couple of hours of cleaning. Another option is that because this market is a frictional market, it is also possible that buyers, when they are in abundance relative to sellers, basically have just a harder time finding matches. And so the task match rate should be lower when demand is high and high otherwise. And so if we plot this task match rate, this somehow happens, but not quite enough to clear the market. So you have a lower task match rate in these periods of high demand and a higher task match rate otherwise, but not quite enough. And so the last possibility is seller effort. When demand doubles relative to the number of sellers, each seller is going to perform almost twice as many services. And the way in which TaskRabbit, the TaskRabbit markets equilibrate is through a very flexible labor supply. But why do we care whether it's buyer rationing, seller supply, or other forms of market clearing? Well, we care about it because this has very important welfare implications for the amount of welfare created and for its distribution across buyers, sellers, and the platform itself. And so we're going to build a very simple model of demand and supply for services with search and matching frictions to estimate these gains from trade generated by peer-to-peer markets for domestic tasks. And this model is also going to allow us to understand how the efficiency of this matching process varies as the market grows. Are there economies of scale and across different cities? Why is San Francisco more efficient at matching buyers and sellers than, for example, Miami? Okay, so without going into the details of the model much, I'm just going to describe the basic facts. There's a measure of B of identical buyers and a measure S of identical sellers. Each buyer is going to choose a number of tasks to post. That's it, their intensity decision, beta. And each seller is going to choose a number of offers to submit, sigma. We're now going to model the decision to participate in the platform, importantly. And the number of trades, M and price, are going to be determined in the aggregate as a function of the total offers and the total tasks posted on the platform. These are going to be known to each buyer and seller, but each buyer and seller is not going to be able to affect these aggregate functions because they are small relative to the market. They're going to take into account, though, the match rate and the price in their optimal decision of effort and how many tasks to submit. So if we're going to look at the problem from the point of view of the sellers, we're going to have a marginal benefit curve that depends on the probability of being matched, on the price at which the seller is going to perform the task, minus the opportunity cost of performing that task. And then we're going to have a tau, which is a commission fee that the platform charges, which is fixed at 20%. This marginal benefit curve is flat because each seller is not going to be able to affect the match rate nor the price. At the same time, we assume an increasing marginal cost of searching and submitting offers. You can think of it, you can think that happens because conditional on being present on the platform, it might be easy to find the first attractive task to which to submit offers, but it might become increasingly difficult to find more profitable tasks for you to perform. And so the equilibrium is going to be at the intersection of these two curves, but the equilibrium has to be consistent also with the market average levels of tasks and offers submitted. And so we can actually draw the market level marginal benefit curve, where every other seller that we were not considering here in this individual problem is actually exerting the same level of effort as our seller of interest. And so as every seller submits more offers, every offer is going to be less likely to be accepted. QS is going to decrease, and it's going to pay a lower price because there's higher competition for each task. And so the marginal benefit curve at the market level is going to be a decreasing function of seller effort. Now, this is true for one market with a given set of buyers and sellers. What happens if the number of buyers and sellers varies? We can think of this using comparative statics. And so we can think about an increase in the number of buyers relative to sellers without affecting the size of the market. And in this case, the services of each seller become scarcer and more valuable. And so we're going to have a shift outward of the marginal benefit curve, which is going to lead to higher efforts on the seller side and to higher prices on average. On the other side, on the other hand, we can actually think about an increase in market size as well. And we assume that the increase in market size might make it easier for sellers to find more profitable tasks. Because there's more buyers, I might be able to find more cleaning tasks that I'm really good at performing. And so we can think of the marginal cost curve decreasing, shifting downward as the market grows. This is going to lead, again, to higher effort on the side of the seller and lower prices because they are competing more for buyers. The theory describes this interaction in a single static market, but you can think of the TaskRabbit platform as actually a set of segregated markets. Remember that we had seen at the beginning that each buyer and seller uses the platform for their cities and matches occur fast. So we can define each city month as a separate market. We have 336 of them. And for each market, we observe the variables that we are interested about. We observe the number of buyers posting tasks, the average task posting rate of every buyer, sellers making offers and their offer intensity, as well as the number of matches and the average transacted price. And some assumptions in the model allow us to impute the number of buyers and sellers that are active on the platform but might not have had a need for a task in a given month or time for an offer in a given month. And so we're going to estimate these.
Chiara?
Yeah.
Mm-hmm. How are you accounting for the fact that this market is expanding over time?
So we are not going to account for that fact. You will see in a moment that the market is growing in all these cities, and we're actually going to take these growth as a way to measure the level of economies of scale in the market. Why we think that this is an acceptable assumption, namely that the number of buyers and sellers growing on the market are not affecting all the efficiency expectations on how the market is going to play out, because most of the growth is driven by awareness of this platform in this moment. So people come to know the platform by word of mouth, and there's not a lot of marketing efforts that are tied to specific market conditions say, it's the Christmas season and you invite people to outsource their shopping on the platform. And so we are just going to use the growing size of the platform as a way to estimate the level of economies of scale. So we're going to have the aggregate matching and pricing functions, and we're going to have some parameters that are related to the utility of buyers and some parameters that are related to the utility of sellers. I'm not really going to go into the details of this, but these are basically going to give us the elasticity of demand to price and the probability of being matched, as well as the elasticity of supply to price and the probability of being matched. And this is the variation we're going to use. These are the most of the 336 markets that we're going to use for the project. And you can see from this plot that the ratio of the number of active buyers to the number of active sellers has been varying a lot, both over time and across the different cities. For San Francisco, for example, the red line here, you can see that there are periods in which there's about a couple of buyers posting tasks per every seller submitting offers. And there are some months in which this ratio is about 6, 3 times as large. At the same time, in any given month, there's some markets in which there's 1 or 2 buyers per sellers, but months in which there's many more. And this is the market size. So as Steve was mentioning, if we look at the number of active buyers in log for the 10 major cities on TaskRabbit, you can see that it's growing. And it's growing quite linearly. So this is in log scale, so it's not an exponential growth in any given city. And the exponential growth is just given from the fact that this platform is basically entering new cities over time. And this is the key identifying assumptions, although I should mention that even relaxing it by considering, for example, just the number of new buyers and the number of new sellers as being independent of unobserved characteristics on the platform doesn't really change the results. And the results are also robust to other market definitions. We're using market as a city month set of activities, but we can use biweekly markets. We can use markets that are just for the top tasks, and the results still hold. But this is what we need. The number of buyers and sellers is independent on unobserved characteristics that affect the efficiency of the market in any given city month. And it's supported by some evidence that there's very limited media and advertising because TaskRabbit didn't have a lot of money to spend on advertising during this period. And there's very limited forward-looking behavior by buyers and sellers. At the same time, there's also some variation in the seller screening that we are exploiting. You saw the huge hump-shaped of the buyer-to-seller ratio, and the huge decrease was due to a change in the policies of TaskRabbit that moved from a really tight screening policy of sellers to a much more lax policy. And so the first result is on the aggregate functions of prices and matching, which support some of the early graphical results that we've seen at the beginning. So the price doesn't really change much with the number of tasks or offers. It's about constant. Doubling the number of tasks only increases it insignificantly by 1.5%, and doubling the number of offers decreases it by 1.3%. So it's a very minimal effect of the number of tasks and offers on prices. What is interesting is the elasticity of the number of matches to tasks and offers. Doubling the number of tasks increases the number of matches by 41%, and doubling the number of offers increases it by 52%. So they both contribute about equally to the creation of matches. And the sum of these two coefficients, because of the Cobb-Douglas assumption, is basically an estimate of the degree of economies of scale, of efficiency that comes from a larger market. A sum of these two coefficients greater than 1 would be evidence of economies of scale. And of course, we don't see it here. And this might be due to the fact that the markets still are growing, but they're fairly small relative to the population in any given city. So the economies of scale are not evident for this size of the market, but we're not ruling them out for larger sizes. Importantly, we're allowing for different matching efficiencies across cities. So we allow for the fact that the same number of offers and tasks can be matched at higher rates in different cities. And that's exactly what happens. If we estimate these productivity parameters, you can actually see that cities like San Francisco and Boston are twice as effective at converting the same number of offers and tasks into matches as cities like Philadelphia, Phoenix, Denver, and Miami. And we have some correlations of to understand these differences across cities. You can think that because this level and nature of services is such that we need buyers and sellers to meet, to transact, you can think of more successful cities as the cities where the distance between buyers and sellers is actually smaller. And indeed, if we plot the median distance between tasks and offers in a given city for the month of May 2014, the last in our data, you can see that San Francisco, Boston, and New York City have buyers and sellers that live much closer together than other cities like Houston, Atlanta, or Phoenix. And another way in which this market is yeah.
When you say distance between buyers and sellers, you mean the matched buyers and sellers or a random buyer?
It's 3 different measures. So you can actually think of the median distance between tasks and the offers that arrived in the 48 hours following the posting of a task. You can think of the median distance between tasks and offers that they have received, and you can think of the median distance between the matched tasks and offers, and they are all going in this direction.
How much is that related to sprawl, just city sprawl? You know, like Phoenix is really sprawled out.
Yeah. So we actually related it to the density of at the city level, and that has some explanatory power, but not completely. So Philadelphia and San Diego are kind of 2 big exemptions on this graph.
So that's what I was stunned by, Philadelphia and San Francisco being over there. So what causes the distance to be big in those cities?
So interestingly, I was talking about someone from San Diego, and the level of segregation might play a role. So buyers and sellers actually live in very different might be living in very different neighborhoods, and so even if you increase the number of buyers and sellers, you're not going to have them live closer together. Another way in which the match efficiency can be explained is through the level of task standardization. And again, this is another measure that is platform specific, but I mentioned that there is standardized tasks and more heterogeneous tasks, but the share of the standardized tasks like moving health or grocery and delivery is different across the cities. San Francisco has a higher share of these more standardized tasks for which the supply might be easier to find and the sellers might be more substitutable among each other than the cities where the match rate is lower. And finally, some results on the utility parameters. What I'm going to say about this is basically that all the estimation imply that we have a very elastic offer supply. Increasing the price by 10% increases the number of offers supplied by about 30%. And the gains from each trade that the platform creates are on the order of $37, which is the difference between the average value for the task for the buyer and the average opportunity cost for the task for the seller. And so because the price doesn't have a lot of room to move and to adjust between these two values, the only two ways in which the market can equilibrate is either through a very elastic labor supply, which is the case that we find, or through buyer rationing. So buyers just having a harder time finding matches when they are abundant relative to supply. And so we can actually compute the benefits of an elastic labor supply compared to the alternative market clearing mechanism, which sees buyers having a harder time finding matches when they are in abundance. And so if we look at the aggregate value of matches on TaskRabbit, and we compare that aggregate value to a world in which the sellers are submitting a fixed number of offers because they have a fixed amount of time in any given month to provide services on TaskRabbit, we can see that 15% higher value is generated on TaskRabbit than if the seller had an inelastic labor supply. And this is equally shared, this increase in value is equally shared by buyers and sellers. There's 15% higher revenue for the platform and for the buyers. And this comes at the cost of sellers because it's more costly for them to search through Task and submit offers. At the same time, our estimates are going to allow us to make a back of the envelope estimate of the value generated by these online platforms, which is on the order of about $10 billion per year in the 18 US cities where TaskRabbit is currently active. Now, is this completely value created, or is this cannibalization of existing industries? I can't tell. I can't attribute the share to each of these two possibilities, but because many of these tasks are tasks like moving help or furniture assembly, where previous standard existing markets didn't really exist, you might think that this is mostly value creation. And so to conclude, we presented a framework to study these possible mechanisms for market equilibration, and we've applied it in the context of TaskRabbit. We've seen that the seller's effort equilibrates the market, and buyers are not rationed when they are abundant. And there are very limited economies of scale as the market grows that don't come from a matching function that displays increasing returns to scale, but from a reduction in search costs to the sellers. And the cities differ in the level of success. Finally, this is a general framework for peer-to-peer markets where the services are typically standardized and generic, and the local and rapid nature of matching makes the market inherently thin and very temporally and geographically defined. And so the advantage of a highly flexible labor supply is appealing for other platforms, but not necessarily achievable by all other platforms. And so part of the reason why Uber uses surge pricing is exactly to try to balance buyers' response to use substitute services and the seller's willingness to provide more rides, as well as Airbnb large inventory of rooms, is a way to expand capacity to accommodate peak season and limit rationing. Thank you.
Chiara, can you talk a little bit about why you think price doesn't respond in these particular cases? Maybe you glanced over it really quickly on that slide where you kind of said there's not a lot of room for prices to move, and I didn't quite get that because it looked like there was a huge difference between the cost of providing services and the benefit.
So the price is actually at about $60, so it's not. It's pretty close to the $70 estimate of the buyer's value. So there's really not much room to go up, at least.
Wouldn't you expect it to go up all the way to 70 in those cases?
In principle, it could. It just doesn't happen because the elasticity of supply just allows buyers to get the task done for something lower. I'm not sure where you're.
So I was wondering about that too. How much of that do you think is a lot of suppliers just have capacity?
So they do, and that would explain why they expand their capacity in periods of high demand. But at the same time, it doesn't completely explain why they shrink their offers, the number of offers in periods of low demand.
So the question is, what's their opportunity cost of time, right? Or leisure, for that.
Yeah.
Right? If they have a pretty fixed opportunity cost of leisure, and they really are substituting between leisure, but because they have this, enough of a supply, the price is going to be pretty insensitive, kind of at the cost of leisure, unless demand skyrockets, which probably it doesn't.
It doesn't. Yeah. Yeah. So that helps explain the fact that price doesn't change. Another possibility is that these tasks, for some of these tasks, the price is very clearly determined. Cleaning is about $30 per hour, and so you can easily substitute away.
I mean, that's sort of the point, right? Like if there's substitution in the market, there's actually a whole competitive ecosystem going on behind the scenes. And that has very different welfare implications relative to the idea that these guys are sort of labor inelastic, right? Or labor elastic, I should say, right? So if you think about the leisure time argument that Steve was making, that's a totally different interpretation relative to the idea that what happens if you raise price a little bit is you leave the market and you go somewhere else, right?
Yeah, but that doesn't prevent supply from still being very elastic.
So I mean, to which extent is there like a substitution between tasks? I mean, so people who do cleaning, can they start doing something else once there's high demand?
There's some evidence. Yeah. So we actually initially started looking at the different task categories separately, but then we realized that there's a lot of sellers actually providing services in many categories. So of the sellers, for example, submitting 10 or more offers, more than 60% of them submit offers in more than 2 or 3 categories. And so that makes dividing the market into different categories separately a little bit trickier.
And the second question, so regarding the tasks, to which extent are the task requesters individuals versus I'm a cleaning company, I'm missing a cleaning crew, I just want somebody very quick.
So my co-author actually has another paper on businesses asking for multiple sellers to provide services like user experience for software development, for example. The great majority, about 90%, are private individuals, or at least they self-identify as private individuals.
Thanks again.
Thank you.